Good morning, all. Myself, Jayaprakash from Team Pragati. I will be the presenter today. So let's start with knowing about the organization and the problem statement which we have selected. So this problem statement is from the Defense Research and Development Organization, DRDO, which is coming under the Ministry of Defense. And the problem statement which we have selected is we are to develop a solution for identification and rendering of human faces in real-time videos. So I am Jayaprakash, and I will be that I am the team leader of this particular team. So before getting to know about our solution, I like to discuss about the differences between facial recognition by using images and facial recognition through real-time videos. So when we talk about facial recognition by using just images, generally we will be using deep learning on deep neural networks algorithms like convolutional neural networks. So what it will be having is it will be consisting of several input layers, which will be images, and then it will be having n number of hidden layers inside that, which makes the model to train and understand and recognize patterns from the image data which we are going to supply. And this particular image model will be used to recognize faces in static images with an higher accuracy than any other algorithms. But when we look into the facial recognition from real-time videos, there are only a few major research projects available in this area. And when we talk about real-time videos, we have to take into consider a lot of things like the accuracy of the prediction, since the video is dynamic in nature, and the pose of the face may be oriented in various angles, and that may that may take a hit in our accuracy. And also the FPS of the input video. So how many frames the video is producing per second. So the FPS of the input video will also determine the accuracy, and the lightings of the video, whether the video is well lit or it is poorly lit. So based on that also, our facial recognition accuracy might be taking a hit. And so now let's move on to our proposed solution. So this is the process of our this is the process flow which we are going to follow. So what we'll be doing is, like, the process flow is consisting of three major portions. The first portion being data acquisition, wherein we will be using libraries like OpenCV, which will enable us to capture, process, and analyze videos in real time. It can be easily integrated with Python, and we can access our hardware components like cameras, surveillance cameras, and so on. So once we are able to capture real-time videos, we have to convert it into several frames. Basically, the deep neural networks can take an image as input. So and video is nothing but a continuous frame of images stacked over each other. So the first thing we'll be doing is we have to split the videos into several frames, and then each frames, that is the images, will be passed to the neural networks as the input, and it will be passing through the n number of hidden layers. So in each layers, we'll be using an activation function which will identify specific patterns in the image. Like if a pixel is very bright, the neural network will be able to understand how much bright it is and what is the color of that particular pixel. So this method will make the neural networks to learn about these input features. And also we will be the problem statement asks us to render this particular face in 3D. So for that, what we will be doing is we have to render the particular faces in 3D by using the software called as Blender. So before doing it in Blender, we have to identify the facial landmarks of the particular faces which we are seeing in images. So for detecting these facial landmarks, we will be using this deep neural networks model. We are having two situations here wherein we can train our own deep learning model by using our own hyperparameters and making this prediction, or we can use Google's MediaPipe, which is an open source platform for detecting facial landmarks, extracting the facial landmarks, and then the post estimation of the human faces, and so on. We can do by using this MediaPipe library. So since we are not having high-end computing available with us, we are going with the second method. But in future, if we are having access to high-end computing resources, we can surely implement our own convolutional neural networks model, and we can give our own hyperparameters. So once once we use this a deep neural network model, it will be providing us with the 3D facial landmarks, which in the face. From the face, it will be identifying some 3D facial landmarks, by using which we can able to detect human faces from the real-time videos. So the next part of the problem is to render the particular faces in 3D. So we can make use of the software called as Blender, which is widely used for image or video processing as well as 3D rendering. And we are also thinking to automate the process of 3D rendering by writing some Python scripts inside the Blender. So this is the workflow of our project. Now let's see the tech stack, software dependencies, and the use cases in brief. So this is the tech stacks which we are going to follow. The front end will be done by using HTML, CSS, JavaScript, and we'll be using frameworks like Django, Flask, and Streamlit to work with Python. And the backend will be entirely taken care by the Python programming. And the core of our application will be this particular deep neural network model. So all the inputs which we are getting from the front end will be passing through this particular model, and we will be getting our prediction. And from the back end, we can store the data and store the data for future uses. So this explains our tech stack. So moving on to the dependencies. So talking about the software dependencies, the first thing we will be needing is we will be needing NumPy, which is an inbuilt array processing tool kit available in Python. By using this NumPy, we can make matrix multiplications, matrix vector multiplications more optimized. Like if you are using an inbuilt list in Python, then the efficiency will not be as much compared to an NumPy array. So we have gone with this NumPy array for our basic processing, and we'll be using, as said, the media pipe library for facial recognition. This can be extended in future, like we can implement our own CNN algorithm for this process. The third main project is main topic is by rendering this particular face in 3D. So for that, we will be using Python scripts and Blender for 3D rendering, and then we will be making use of OpenCV. As I explained earlier, this will be enabling us to capture the videos in real time and processing those videos. So talking about the use cases, moving on to the use cases. So the first use case which we have here is in accordance to the problem statement and the organization which gave this particular problem statement. So this problem statement was given by DRDO. So we found applications where it can be where this particular face rendering and the recognition can be used in military area.
యూస్ కేస్ డయాగ్రామే వేశారు, ప్రణీత్ వాళ్ళు వేయలే. అరే నోట్ చేసుకున్నాను.
Yeah, okay, talking about the use cases, this facial recognition model can be used to protect the bases and sensitive areas in military, which means that if there is a sensitive restricted area in some military bases, and if a person is trying to enter that unauthorized person is trying to enter into that area, the surveillance camera can capture their faces. But here comes the need for 3D rendering. Why? Because the cameras might not know it is a real person or it is just a 2D image of that person. A person can show the image of an unauthorized person and they can break into this particular area. This is where the novelty comes in. So by using the 3D landmarks, we can estimate whether it is a real person or a 2D image. When we talk about images, it will be just 2D static images. So when a person is trying to use the 2D static images, it will not be recognized as a human, and so the authorities can be easily notified by using 3D rendering. And in criminal investigations also, we can render the face of the culprit, which is available in the CCTV cameras. The quality of the CCTV cameras will also depend, like it will also have an impact in our 3D rendering. So and if we need to recognize missing people in crowded railways, we can easily do that with our proposed solution. So by this we conclude our presentation. Thank you.